Hey everyone, welcome back to another episode of the Weekly Coder. I'm Chris, and today we're going to go ahead and continue on with our Pac-Man Clone tutorial. We left off last week with creating nodes, which as you may remember was quite a bit of work to get set up, setting up all the nodes, defining the neighbors, and then all of that. So today we're going to make it so that Pac-Man can no longer freely move wherever the heck he wants, but instead we're going to restrict him to just moving from node to node to node. Okay? So there are a couple of things that we're going to have to do first. First, if you look at Pac-Man, you'll realize here that he's actually not sitting on a node directly. Well, he's sitting on a pellet, but this pellet specifically doesn't specify that it's any kind of node for intersections, right? So he's right now in between nodes. So like right here is an intersecting node, here's an intersecting node, here's an intersecting node, here's an intersecting node. The node that he's currently on is just a pellet, so we can't determine what his current node is based on where he's at. So we actually have to move him to be on a node that has an intersection available for him to move to. Right, a neighbor available to move to. Because this pellet has no knowledge of any neighbors, but the node right next to him does. So the first thing we're going to do is we're going to move him onto that node. Okay, and that's 14.91. So we're going to go ahead and make this 15 to be right directly on the node. Okay, that's step number one. So what we're going to do next is we're going to go ahead and create a new script, and the script is going to be called GameBoard, because we actually need a script or a class that's going to, along with the help of an array, keep track of all of everything on the board, whether it's part of the wall, whether it's a pellet, whether it's Pac-Man himself or the ghosts. It's going to keep track of all of these things inside of an array so that we can easily reference what is in an array. I mean, we could always use GameObject.find if we tag all these or by name, but that actually would consume quite it would definitely consume more resources than we would want to at this point. So with an array, if we store everything in an array and then just reference the X and Y locations in the array of the positions of the objects that are stored in the array, then we have a lot better optimized way of doing this, right? So first thing we're going to do is we're going to create an empty. So up at GameObject, go to create empty, and we're going to call this game. And then we are going to go onto the game here, game, right? The inspector, add component, and we're going to do C# script, and we're going to name it GameBoard. Alright, so create and add. So this probably added it to the assets folder. Yep, so we're going to go ahead and take this and drag it into the scripts folder. So now in our scripts folder, we've got this GameBoard script, and it's also attached to the game, the game object. So what we need to do first is we should probably set our script execution order, right? Because the script execution order allows us to set the order in which we want scripts to be instantiated in. So right now it could potentially be that Pac-Man will load first and then GameBoard loads, but we don't want that because GameBoard is going to store all of our nodes. Pac-Man is going to have to reference a node from the array to find out what his current node is. So if Pac-Man loads before GameBoard does, then when Pac-Man tries to reference the node, it's going to be null because it hasn't been stored in GameBoard yet. So we always want to make sure that the GameBoard class actually instantiates first before the Pac-Man class does. And the easiest way to do that is if we go up to Edit and go down to Project Settings. If we go to Script Execution Order, and you'll see I've already, let's see here, I know this must be from a previous thing, but right now there shouldn't be anything in here. Okay, so it should just say default time and with nothing. So to set the order, we simply just click on the Add button, and the first thing that we're going to add is GameBoard, and then we're going to add Pac-Man. Okay, So game board's going to instantiate first, and whatever is in the game board start method is going to go ahead and run, and then Pac-Man's going to be instantiated. So we're going to apply this, and I'm going to open up our game board script. Okay, and the game board, we've got our start and update methods. So the first thing we're going to want to do is we're going to create two variables. One that is going to define the width of our board, and the other one is going to define our height of our board. And those are not in pixels or anything, those are in actual units. So we're going to create a private static int, and we're going to call that board width. And we're going to set that equal to 28. And private static int board height, and that one's going to be 36. And if you're questioning these numbers, where am I getting these from, is if you count every single unit here, we've got 28. And if you count them from top to bottom, they're 36. And that's the actual Pac-Man game board width and height. Okay? So now we need to create an array. And this is going to be, the array is going to be of type GameObject. Okay? And it's going to be multi-dimensional, so it's going to store an X and a Y, right? And we're going to create a new GameObject array, and we're going to initialize it with our board width and board height. Okay? So these are going to be the locations that are going to be stored. So like for every node that it's going to iterate over to store into this array, it's going to say, okay, what's my current X, what's my current Y? This is the game object I'm going to store here. So we're getting the positions that the game objects are located in, and then we're getting the game objects themselves stored in that position in the array. Okay? So, and how do we do that? Well, we are going to create an array of objects. So we're going to do objects equals game object, right? Yeah, dot find objects of type. Okay, and then we're going to do type of game object. So we want to iterate over our entire scene of objects, and we want to create an array of objects. Oops, that's not right. We want to create an array of objects that is going to contain every single object in our scene. Okay. So then we're going to iterate over this. So for each game object, we're going to just call this O for object and object. So what we're doing essentially here is in the for each loop is we are for every basically for every object that we have in this objects array, we're saying assign the object at the current iteration to this variable O, and it's of type GameObject. We're going to go ahead and get the position. So position equals O.transform.position. And you might notice that I'm using position instead of local position. And the reason for that is that we've created empties, and we've thrown all of our pellets and all of our maze objects into these empties. So what happens is their local position is now relative within those empty game objects, and those positions no longer match our world positions. So we can't use local position there. We have to use position, which is in the global space of, Unity, where everything else lives. So by using position, we're actually getting the position outside of the empty that the game object is in, which is what we want, because we don't want Pac-Man to travel inside of these empties. We want him to be outside in world space. Okay. So here we're just going to do, we're going to do a sanity check, and we're going to say if O.name doesn't equal Pac-Man. Okay, because we want to only store the actual game board objects, so like the walls, the pellets, all that. We don't need to store Pac-Man in the array. Otherwise, because Pac-Man is in a position where one of our pellets is, and we don't want to overwrite the position of the pellet with Pac-Man, because that would break things. So if it doesn't equal Pac-Man, then we go ahead and do board mathf, and we don't need to do absolutes. because everything is positive. So we'll just do, we'll cast int position.x and int position.y. And we're going to set that equal to O. Okay. So basically, at the position that we're at in the array, or sorry, at the position that we're currently at with objects. So let's say we've found a pellet at x equals 5, y equals 1. Then we're going to, in our board array, 5, 1, store O. So O, the game object that is not Pac-Man, is going to be stored at this position right here. Okay. Otherwise, we don't really have to do anything here, but just for the heck of it, I'm going to show you that, you know, it's going to find Pac-Man still. So we're just going to do debug.log found Pac-Man at, and then we're just going to do the position. Okay. So we're going to add every single item. If it finds Pac-Man, then we're just going to get an output that says, hey, we found Pac-Man. Just like, you know, hey, there's Pac-Man. We don't really care about it, but Pac-Man's right there. Alright, so that's the game board script. Alright, so I'm going to go ahead and run this the way it is. Okay, so we're going to click back in Unity. I'm going to press play. And if we'll look at the console output, you'll see that it says found Pac-Man at 15.7, which is correct because if we click on Pac-Man, we'll see that his X position is at 15 and his Y position is at 7. So that's perfect. So it's actually working exactly the way we need it to. Okay. So next, we're going to go ahead and jump into our Pac-Man script. And we need to add a variable here. And that is going to be a node type of variable. So node. We'll call this current node, or you know what? We'll make it private as well. So private node, current node. Okay. So the current node is going to actually store what Pac-Man's current node is. So where is he actually at right now? On which node? Okay. So in order to find our current node, we're going to have to write a method. And let's go down here to the bottom. And we're going to create a method called getNodeAtPosition, and it's going to return node. So getNodeAtPosition, and we're going to use vector2 as a parameter, and we're just going to call it POS. So we're going to call this game object. We're going to create a game object. We're going to call it tile, and we're going to find. So GameObject.find game. Because that's what we've called our empty that we attached our game board script to. So we're going to find game, and then we're going to do get component, game board, and we're going to get the board of game board, so the board array, and then we're going to get the position that we passed in. So yeah, we're going to cast int and position.x and int and position.y. Okay. So basically what this does is it creates a game object called tile, and we're finding the game, okay, which is the empty that we created. We're grabbing the game, or the component, the game board script, from this game object, and then we're getting the board array, and we want the object that's stored at this position, x and y, okay? And the position we're getting that's going to be passed in here when we call this method. Alright, so once we have our tile game object, we can check to make sure that if tile doesn't equal null, because if it does, then we don't really want to return, or we don't really want to check. Okay. We got to make sure that tile doesn't equal null, because if we try to get the component of tile, the node component, and it does equal null, then we're going to get some kind of null reference error that we can't access it because it doesn't exist. So we're doing a sanity check here, and then we're going to return, if it doesn't equal null, we're going to return the node component. okay? Because that's what we're returning. And, you know, if it does equal null, we're just going to return null. So, get node at position, right? That's what we're gonna call our method. And then we're either going to return the node component of our tile that we've got at that position, or we're going to return null. So, now that we've got that, we can go back to our start method, and we can create a node. Okay, get node at position, and we're going to pass in our transform.local position. So of basically Pac-Man, because that's the transform that we're using here. So Pac-Man transform.local position. So that's what we're getting the node. Okay. So now remember, this node could be null. So if node doesn't equal null, then we set our current node equal to the node. Simple enough. So we now have a current node. So just to check this out, we're going to do debug.log, and we're going to output our current node. Okay. So we're going to click play. And if you look, our current node is pellet 62. So if we go to pellets, and we're in non-nodes, so it wouldn't be in here, it would be nodes. Pellet 62 is indeed a node, and if we click on it, it's at position 0, -18, but that's because it's inside of the nodes. That's why we're getting the actual position and not the local position of the pellet. So the actual position of this is the same as Pac-Man's, which is why we were able to get back pellet 62. So next, we're going to go back into Pac-Man, into the Pac-Man script, and we have to modify, because right now, if we click play, we can still move Pac-Man to wherever the heck we want, which is what we're trying to avoid by using these nodes, right? So we're going to restrict his movement now, right? So the first thing we're going to do is we're going to go into the Pac-Man script again, and we're going to create a method. I'll create it down here, and this one's also going to return node, and we're going to call this one can move. So basically it's a question. Can I move? Right? So the thing that we're doing now is with nodes, right? We've got neighbors, and neighbors have, and also valid directions. So what we're going to do is we're going to press a button, and then we're going to call the can move method. And then from the can move method, it's going to check to see, hey, is there a valid direction, first of all, in the direction that the player pressed the button? And if there is, then we're going to set the position of Pac-Man to the node, to the neighboring node. Okay, so that's basically what we're doing. So here we're going to do is we're going to create a node first. So move to node. That's the node we're going to move to. We're going to set it equal to null in the beginning. And we're going to iterate over, the current neighbors are for int I equals 0. I is less than current node dot neighbors dot length I plus plus. Okay, so we're iterating over the current node's neighbors. Okay, so let's say the current node has 3 neighbors. We're going to check every single one of those to see if the valid directions at the current index is equal to the direction that gets passed into the can move method. Okay, let's say if current node dot valid directions I is equal to D, which is our direction that we passed in, then we're going to set our move to node equal to the current node neighbors I. And finally, we're going to return move to node. Okay, so let's break this down one more time here. We're iterating over the neighbors, okay, of the node that we're currently at. at every iteration, we check the valid directions at the index, okay, that we're currently at, to see if it's equal to the direction that we're trying to go to. And if it is, then we're going to set move to node equal to current node, the neighbor at the current index of the current node, right? So, and then we also have to break, because if we didn't break, we would run over this loop again, and we could potentially, never get there, and then we would return move to node as null. Which brings me to the next part, which is we're going to create another method. We're not going to use this move method, okay? So one thing we got to remember to do is we have to actually comment out move, because we don't want to allow movement to happen anymore the way we're doing it now. So, but we're going to keep it because we're eventually going to go back to something similar. So for now, we're going to create a new method called move to node. And we're also going to pass in our direction that we want to move. Yeah, that'll work. Okay, so move to node. It's going to be pretty simple. First, we're going to create a node. Yeah, our move to node. And that one's going to be equal to can move. We're going to pass in D. Okay? And then we're going to say if move to node doesn't equal null, because remember, it can return null if it doesn't find a valid movement. And if it doesn't equal null, then we're going to set the transform.local position, so Pac-Man's position. I'm going to set that equal to the move to node dot position, dot transform dot position. Okay, so again, we're getting position and not local position because we have to work with the global position and not the actual position within the empty that the pellets are stored in. And then finally, we're going to set current node equal to move to node. Okay. So this method gets called, all right. Instead, well, let's see here. We called move right here, which used to be here, and basically it would just move Pac-Man based on what our direction's currently set at. So the other place that we can actually control where Pac-Man goes is in our check input method, because it gets called every frame. So once we set our direction, all we have to do is we have to say move to node direction. Okay. We do this every time. Someone may be thinking, hey, why don't we just put that at the end after we do all of our if checks, because we're going to move anyways. But what would happen there is if we did that, because check input gets called at every frame, the move to node would then get called at every frame, and it would continuously move from node to node to node as long as it could in the direction that it's giving. So we don't really want to do that right now. For right now, we just want to move from node to node whenever a key is pressed. Okay. So let's go ahead and save that. I click play. Okay, so now we've got Pac-Man faced to the right, so we should be able to move left to right, up and down. So let's see. All right, look at that. We can move Pac-Man from node to node, and he can't go through walls any longer. So he can go all through these nodes. Oops. Looks like we have an error here. Pac-Man can't go down from this node. So let's check out what's going on with that node. That would be this one. Well, I see a problem. We've got 2 neighbors when we should have 1, 2, 3 neighbors. So let's add another neighbor here. So let's make this 3. And add, let's see here, call it 146. Let's set this one to pellet 146. Alright, so let's press play. Okay, now we're good. And now that we've got Pac-Man moving from node to node, not being able to go through walls, it's really kind of cool, right? Starting to be more like a real Pac-Man game. In our next tutorial, I think, what have we got scheduled for the next tutorial? Continuous movement between nodes. Okay, so our next tutorial is going to basically allow Pac-Man to not jump from node to node, but instead continuously move from node to node. So like, instead of actually just jumping from here to here, we're going to press the left button and it's going to continuously move until it gets to that node and then stop. And then we press it again and it's going to move. So there's going to be an actual movement instead of a jump from node to node. Because right now he just sort of looks like he's teleporting through the game, right? So that is our movement for right now. And that is going to be the end of this tutorial. I think it's long enough, but I think it's getting us closer to a real Pac-Man game. So here we are, the end of the video. Hope you guys enjoyed it. If you liked it, give me a thumbs up. Comments down below. If you've got questions, feel free to ask. Don't forget to subscribe to the channel. And thank you guys for watching, and I'll see you next week.